Welcome back to PSC Tech Byte. Today I want to talk with you about the rate limit headers, which have been introduced by the IETF in draft so far, and which allow us to improve the throughput of our solutions when consuming Microsoft Graph and SharePoint Online REST APIs. The rate limit header gives you information about the maximum amount of requests that you can make in a time window. The rate limit remaining gives you information about how many requests you can still do in that time window. And the rate limit reset will give you information about how much time you have to wait to refill the quota and go back to the actual full quota of rate limit that you have in a time window. Whenever you are over the 80% of resource units per app per minute consumed by your application, those headers will start coming inside the response headers of your requests. And by handling the headers, you can, rather than being throttled, simply slow down the frequency of your requests and improve the throughput of your solution. So, like always, let me move to the demo environment and let me show you how to leverage those headers in action. So here we have a .NET application, which is just a demo app that I can use to show you how the rate limiting works. And here I have an application which relies on a method, this initialize and run async, which will use an HTTP client with a custom throttling handler provided in the constructor. And this throttling handler will take care of handling throttling, if any, as well as rely on a rate limiter object, which will keep track of the limit and the remaining requests in a time window and will slow down the request in case it is needed to slow it slightly down to wait and in order to not reach the limit and to not get throttled. So if I will run this application internally, it will simply make a bunch of requests targeting SharePoint Online using SharePoint REST APIs, Microsoft Graph and CSOM. So let's run the application and let's see what happens when we handle the rate limiting like I'm doing right now. So let's start it and see how it behaves. We will see a bunch of requests in parallel, here we are, and soon we will start seeing that we get the rate limit headers back from the responses from Graph or SharePoint REST or CSOM, and we handle those rate limit headers. So here we made 200 and something requests in 10 seconds, now 500 in 20 seconds, and soon we will see the rate limiting in place, and we will see that we will need to slow down the frequency of the requests made by the consumer application. And here we are, you see we have the rate limiting. So now let me stop it and let me disable the handling of the rate limiting and see how it behaves. So let me run it again. And now that we don't have anymore the rate limiting handling, if there will be too many requests, we will get throttled and we will see that application gets the throttling header. As you can see here, we get the 429 and we get throttled. And as you can see, now actually the application is also compromised by the previous test that I made. But we can clearly see that because of the throttling, we get back a request from SharePoint to delay and to wait for 14 or 13 seconds, and we have to wait and we perform in a worse way compared with before. And as such, this is a worse solution compared to the one where we use the rate limiting handling. So this is just to give an idea of what you should do in order to properly consume Graph and SharePoint REST or CSOM, being able to maximize the throughput. Then if you use libraries like, for example, the PnP Core SDK, in that library we have a native support for rate limiting headers. You simply need to enable it in the settings, and then you can rely on that capability out of the box without having to reinvent the wheel or reusing this kind of code that you can find in this demo. By the way, the demo that I just showed you is available on GitHub. If you go under github.com/OneDrive/samples, in these scenarios, you can find a throttling rate limit handling demo made by Bert Janssen, and here you can find detailed instruction about how to use it, and you can learn how it works. And again, here you can see the benefit of using the rate limiting compared with just using the throttling. As you can see, the throughput can be better when you use the rate limiting instead of using just the throttling handling. Like always, thank you for watching this video. I hope you found it useful, and I want to wish you a very Merry Christmas and a Happy New Year. See you in 2024. Thank you.